Hi everyone. Thank you for joining us to discuss the fascinating topic of universal semantic-less texture boundary detection for microscopy in general and for metallography in particular. I'm Oren and I'm from the Technion and NRCN. Before we dive further into our research, it's important to highlight that this work is a result of an incredible collaboration. We have had the privilege of working alongside experts from Technion, Tel Aviv University, and NRCN that share our passion for advancing computer vision and metallography. So as you probably know, material science is the study of material properties, which is based, for example, on understanding how it is influenced by its mechanical composition, microstructure, and manufacturing process. Metallography is the study of the microstructure of metallic alloys, or more generally, of any material in length scale, usually ranging from nanometers to millimeters. This is usually a very texture-oriented imaging field. Investigating the microstructure of a material allows one to discover important properties of that material, such as the corrosion behavior, electrical properties, and so forth. Microstructure study is therefore considered to be among the most beneficial and effective fields for understanding materials' properties, and is needed for building new bridges, electric cars, or lightweight airplanes. That's why the automated analysis of textures has always been a topic of importance in metallographic imaging and in microscopy in general. Those analyzed textures are used in a variety of applications, and as such, texture analysis is at the backbone of most, if not all, other vision tasks. Thus, we wish to develop a universal texture representation, or UTR. This representation will allow us to segment any texture image in any domain and even develop a universal texture boundary detector, or UTBD. Crucially, such segmentation algorithms should work on texture images that have no semantic meaning, such as metallographic textures. Hence, the vast literature on edge, contour, and semantic segmentation cannot be used as is in our context, including segment anything models that might succeed in cases in which semantic appears in the image but fails when those are missing or form a texture collaboratively. Moreover, as the problem of boundary detection in images of new and different domains is crucial, we would like to develop self-supervised or few-shot learning methods that can learn to detect boundaries quickly on new domains. This is why, aside from the common work on current relevant general image segmentation datasets, such as BSDS, we construct a new dataset, namely Texture Boundary in Metallography, or TBM, that is as general as possible with annotation that correspond to the task of texture boundary detection in microscopy and especially in metallography. This dataset serves as a benchmark for our research and the following future work that establish the direct contribution to the needed sciences. To evaluate the role of context in modern boundary detection, we run IDETER, a state-of-the-art edge detection transformer model, in two settings. In both cases, we randomly select windows of size 100 square. In the first one, we run IDETER on the entire image, but evaluated the algorithm performance only on the random window. In the second setting, we place the randomly cropped window in the center of an otherwise completely black image, and then run IDETER. In both cases, we used IDETER, which was trained on the training set of BSDS 500 and tested on the images of the test set. As can be seen, context play an important role in the algorithm's performances. So our proposed approach will center on developing a UTR through the utilization of a pre-trained vision transformer in Painter model. The UTR will aim to impart the model with a profound understanding of textures completely independent of semantic constraints. The pre-training phase will leverage the DTD extensive texture dataset. Afterwards, fine-tuning will be carried out to adapt the model for UTBD. This will involve the reconfiguration of the model to predict pixel-wise segmentation masks that sketch texture boundaries as opposed to in painting missing regions. And that's it. Thank you very much.